Bene, bentrovati. Andiamo avanti a parlare di dati, machine learning e intelligenza artificiale, perché se quando cercate una canzone su Shazam, Shazam non sa se la cercate perché vi piace o solo perché non la conoscete. Se fate un like, mettete una foto, una condivisione, ci sono tantissimi dati che vanno interpretati. E c'è un'azienda, Quantcast, che ha trovato il modo di interpretare la mole di dati che vengono condivisi dalle singole persone e poi ovviamente dalla massa per cercare di aiutare le aziende che fanno pubblicità a fare delle pubblicità che vi piacciono davvero, in modo che non siate lì ad aspettare i 5 secondi per fare skip sul video prima dei video o saltare direttamente tutte le parti pubblicitarie per andare direttamente ai contenuti. Visto che oggi sul web gran parte dei contenuti sono pagati dalle pubblicità perché gran parte delle cose che facciamo è gratis, allora l'impegno di Quantcast è cercare di fare in modo che vi interessino anche questi contenuti pubblicitari. L'intervento è del co-founder e CEO di Quantcast ed è in inglese. Visto che qui c'è un po' di movimento, ve lo ripetiamo. C'è un'app su iPhone e su Android, si chiama Wired Fest. C'è la traduzione simultanea dall'italiano all'inglese e dall'inglese all'italiano per chi volesse sentirlo in italiano. Lascio la parola a Konrad Feldman.
Thank you. So you're hearing about lots of advances in artificial intelligence today, and barely a week goes by where we don't hear about some other new innovation, and we're beginning to see its application in so many different domains. And this is a result of a lot of experimentation and progress in the underlying technologies, but also then the application and exploration of how these machine learning techniques can be used to solve particular domain problems. And whenever we see innovation, we might think about the light bulb moment, where suddenly you have the idea and everything's clear and perfect, but it rarely works like that. And to look at an example of that, we can actually look at the light bulb. So Thomas Edison didn't invent the light bulb, but he did invent the mass market light bulb. And he set out to find a way of producing light bulbs that were cheap enough and long-lasting enough that they could be used by anyone. And he did that, not on his own, with a lot of researchers in what was probably the world's first industrial research lab. And they experimented with everything. Every one of the components had to be evaluated and compared to see if it would work. And most of the things they tried didn't work. And it's reported that a journalist once asked him, "What's it like, Mr. Edison, to fail 10,000 times?" And he said, "I have not failed once. I've discovered 10,000 ways not to make a light bulb." And it wasn't just those individual examples. Through experimentation, they were understanding how the raw materials available to them could operate together to solve a problem. They were understanding the entire domain. And as we start to apply machine learning in new business areas, we have to experiment to understand how the techniques, as they are today, or as we advance them, can be most appropriately applied to solving those problems. And I'll talk about one of those areas today, advertising, which is an exciting area because it's data-rich and we can measure results quickly. So similarly, in terms of artificial intelligence, we hear so much about it today, many people might think it's just been invented. But the reality is, where we are today is the result of decades of research. Tens of thousands of researchers and now corporations around the world have focused intensely on building these techniques. It has not been a linear path. There have been lots of ups and downs, and I'm going to touch on a few of them. This is not a definitive timeline, just some examples. In 1948, the father of modern computing, Alan Turing, published a paper in which he hypothesized about machines which could organize themselves. So at a conference on artificial intelligence in 2017, the very first conference on artificial intelligence was in 1956. Actually, that's where the term artificial intelligence was born. It was organized by John McCarthy at Dartmouth, and about 20 prominent researchers over the space of a summer program of 6 weeks got together and talked about the ideas of computers that could respond with some of the ingenuity of human decision makers. And they got really excited. They left that conference and they went back to their universities, and they got their colleagues excited, and they got their students excited, and they got the government excited. And of course, back then, the government provided most of the funding. And the first boom of funding in artificial intelligence started. And there were lots of breakthroughs. In 1957, the concept of neural networks was really born when Frank Rosenblatt invented the perceptron. Research had been done in the 40s looking at neurons in the brain. You know, something about our brain gives us the ability to learn. And McCulloch and Pitts researchers had proposed an artificial neuron, which could take inputs through some function, produce an output. Well, Frank Rosenblatt developed a learning algorithm whereby this artificial neuron could learn from examples. And there were lots of other similar advances that felt groundbreaking. And there was massive excitement. And many of the researchers felt that it was just a matter of time, maybe 20 years, where they would have created computer systems that offered general purpose intelligence, that could perform any task in the same way that a human could. But in fact, as people got deeper into it, they discovered that the problems were harder than they first anticipated. Even the perceptron couldn't solve basic logical operations. And as more and more of these problems were discovered, people became a bit disheartened. And the people that provided the funding, the governments, became disheartened, and there was less funding, so there was less research. And for a period of time, known as the AI winter, the level of investment and research really dropped off. But that research was all still going on. There were still people doing some of it, and even breakthroughs like expert systems came during that period. You know, fast forward, and things started to pick up again. In 1992, IBM's TD Gannon, which was a backgammon playing computer, was able to play at the same level as world-class players. So board games are popular for AI tests because the rules of the game can be simply coded, but the complexity of successive moves means that you have to have strategy, you have to have planning, you have to have learning to be good. And those are all features we associate with human intelligence. TD Gannon not only was able to beat world-class players, but the way it played, the strategy it used, was considered very unusual. That is the strategy that is used by all professional backgammon players today. So the computer discovered a new way of doing it. 97, IBM's Deep Blue beat Garry Kasparov. It was a breakthrough moment. People have been working on chess computers for a long time. The first chess computer, it didn't play a full game, was developed at Manchester University in 1951. In 96, Deep Blue lost to Kasparov. Come back a year later, people had made the software better. Computers get faster every year. So the computer got faster, and it was able to beat Kasparov. Now think about this. That was one of the world's fastest computers, one of the top supercomputers in the world. Today, every one of you in your pocket have a computer with more raw computing power than Deep Blue. So the advances in computer power help AI. They also enable us to develop more software. But the final leg of the stool is data. So I started my research in AI around the time of TD Gannon. And I was working in neural networks. And neural networks need data to learn from. And it was really hard to get good data sets. But then along came the internet and the ability for researchers to collaborate and share data. In '96, there was the MINT data set. This was a data set of people's handwriting. We can all recognize handwriting. Computers weren't very good at it. This data set allowed researchers to enhance their techniques dramatically in a short period of time. And the state of the art in optical character recognition leapt forward. 2006, Netflix released a data set available to anyone of 100 million ratings. This is a fantastic data set for machine learning researchers. And if the data set wasn't enough, Netflix offered a $1 million prize for anyone that could improve the prediction engine by 10%. One team had beaten Netflix just a little bit within 1 week. Within 2 weeks, 3 teams were better, but only by 1%. Within 1 year, 20,000 research teams around the world had registered to work on this problem. And in 2009, one of them claimed the $1 million prize for enhancements. So between better hardware and more data, we're able to then develop and enhance the software that powers AI. And all three of these advance together. IBM's Watson won at Jeopardy. Facebook used the fact that they have a massive data set of photographs which have been labeled by people to train computer systems to recognize people. More recently, in 2005, Google's DeepMind AlphaGo beat the world champion at Go, considered much harder than chess. And actually, just this week, it's beaten the most recent world champion. What was really interesting here, though, about AlphaGo was Deep Blue was essentially programmed how to play chess. It was told the instructions, it was told different strategies to play, and it used its number crunching ability to evaluate lots of moves. AlphaGo learned how to play chess learned how to play Go by trying it out, seeing if the rules were okay, and seeing if it could win. And it started playing against people, but people are really slow, so it played against itself. And the computer system learned how to play Go, playing itself iteratively, time and time again. Now, the computer system that was necessary to play a board game probably cost just the computer in excess of $100 million. But just think about the phone in your pocket today compared to Deep Blue. It's not that far away until we all have easy access to that level of compute power. And it's going to enable us to do some fantastic things in our personal lives and in business and in government using AI. So we're now beginning to see AI move into lots of different fields, and that itself is driving innovation. The field that we operate in is programmatic advertising. So over the past few years, advertising has started to be decided in real time. Much like you see with search advertising is happening to everything else in advertising. And it's a problem that lends itself nicely to machine learning. It's very, very complex. You know, every advertising campaign is different. Every consumer is different. Our behavior changes all the time. So the task of machine learning is to understand our behaviors, understand what we like, understand what we might like, so that we can make the advertising more relevant. The other thing that's nice about this problem space is we can get a measure of success quickly. With machine learning, you have goal-based systems. So we want to be able to evaluate, are we doing well? Did we win at chess? We can evaluate, did we perform better in an advertising campaign? Did we create a better experience for consumers? And that allows us to advance and iterate on the approaches that we use. So there are lots of fascinating problems in the advertising space for machine learning. Perhaps the most fundamental is understanding consumers and consumer behavior. And people think about consumer behavior using categories that we understand. In advertising, age and gender and income. Well, machines don't need to be limited to such a few number of dimensions. In fact, the systems can evaluate millions of features for every consumer. And in building these models, they can build one not just for all consumers together, but a unique model for each individual consumer. So what we're asking the computer systems to do is to understand consumer behavior and then also understand the ideal characteristics of people that would be interested in different products and services. So we're building predictive models for every consumer, which are then updated continuously as more information is made available. This is another great example of where AI systems, just the sheer power of computing today, can outperform people because of the amount of data they can consider. So what we're creating is a live model of all consumer behavior across the planet. But within that, I said model. And models are at the heart of machine learning. And we don't know what the best model is. Programmatic advertising is less than 10 years old. We're still in the early stages of discovering the best way to use machines and data to create better advertising experiences. So to advance, we have to innovate and we have to experiment. And of course, like many companies, we have sort of unstructured innovation through things like hackathons. We had one 2 weeks ago. Probably about 100 of our engineers in our headquarters in San Francisco and our other engineering centers around the world participated in this. And that can be really good, and you can get some sort of unexpected advancements. But we found that central to our ability to advance our approach and advance the machines is actually structured innovation, much like Thomas Edison employed in his lab. So we've actually set up the way our business operates to enable all of the different teams that have to innovate. There's lots of challenging problems. We want to be able to understand data. We want to build models. We have to decide which advertising opportunities are good and how much they're worth. We have to decide which advert to use and how to manage a portfolio of all these advertisements to deliver great results for an advertiser. So there's lots of individual tough challenges, and they all have to work together to create the outcome. So we've created a framework whereby it is easy for our engineers and our product teams to experiment, to run structured experiments, and rather than spend weeks and months arguing over which algorithm we think is going to work better, we test them out. And we run them, and they run in production on live campaigns, and a portion of them, and you get the results and the feedback, and you see if it gets better. And you know what? Most of those experiments don't work. Most of them don't work. And that's okay, because there's a lot that you can learn through failure. In fact, you can often learn more than through success. Because we're controlling all of the different components, much like Edison controlled the components of a light bulb, when something doesn't work, we can start to understand why, and we can strategize about a new approach that we could use to improve it. And so what you see here are examples of different improvements in different areas, modeling and automation and optimization. But for every one of these that exists here, there's 10, a dozen, probably dozens of failures that sat behind it. And I think the key to us being able to make significant progress in this space has been that we've been able to structure experimentation such that it is low cost and fast. And that's been important to discovering the right ways of creating these advances. And what's really exciting about this space is we've got a long way to go. Most of the advertising that you see today on television, on the internet, is not very good. Most of it isn't very relevant. And so this is a problem space where most of the problems are still unsolved. And I think we'll see very significant advances in the next 10 years in this field, as we will in so many other domains of business and in so many other aspects of our society. I think the key with all of this, when you start applying machine learning to any new domain, it can be frustrating. It can be disheartening. I think we saw it in the history of the development of AI. It was disheartening for lots of researchers. Lots of researchers have spent a significant portion of their career believing they were on the verge of a breakthrough. And then the funding dried up. Fortunately today, we're not dependent on governments funding enhancements in AI. Many companies around the world spend enormous amounts of money on advancing AI. If a small company like Quantcast, we've probably spent, hundreds of millions of dollars on building these technologies over the last 10 years. If we've done that, just think about the amount that's been invested by all the different companies around the world, many much larger companies. And we're seeing the culmination of those advancements and those improvements, and we're all benefiting from the advancements that others are making. So if you're looking at a problem involving machine learning, it's probably hard. All of these problems look hard when you start, and sometimes you know where you want to get to, but you don't know the exact path. I think embracing an experimental approach where you're structured in your innovation and you free up your colleagues to to try things out and be accepting of failure can go a big way towards actually getting significant progress in the long term. Thank you.